then she can stick a star or heart sticker on it. How many possible combinations are there? So she can pick pink, blue, yellow paper, and she can stick either star or heart. So she's having 3 combinations, 3 choices with paper, and for each choice of paper she has 2 choices for sticker. So we can just multiply them and find the number of combinations, right? For P, 1, 2, for B, 2, 3, and 4. So 6 combinations is the total combination possible for the 3 choices of paper and 2 choices of sticker. Just we have to find the number of choices for each option and multiply them, then we'll get the total combination. So in the next question, Anne's family is planning to go to New York, Washington DC, Ohio, Maryland during the holidays. They can get there by car, train, airplane. Given these choices, how many different combinations does the family get to choose from? So the destinations are 4 choices are there, and for the transportation they take 3 choices. So total number of combination is 2. Next, a coin is tossed and a card is drawn randomly from a deck of 52 cards. How many different combinations are possible? So number of cards choices is 52. What about the coin? So when a coin is tossed, you'll get either head or tail. So that is 2 combinations, 2 choices possible. So now the total combination possible is 104. So as we learn about combination, there is 2 important points. One is called combination, the other one is called permutation. The very basic difference is that in finding a combination, if the order doesn't matter, then we call it as combination. Okay, if the order does matter when you are finding out the combination, then we call it as permutation. For example, if there are 3 balls A, B and C, okay, when I am picking a ball, like 2 balls from this, I am going to find all the combinations. Okay, so as per the combination, we'll just write A B, B A, A C, C A, and B C and C B. Okay, these are the 6 combinations we'll get. Okay, so when we pick a ball, first ball should be A followed by B, first ball should be B followed by A. If that condition is there, if that orderliness is there, okay, then we'll get 2 combinations. If I don't mind the order, I just need to pick 2 balls and the combination is A and B. Okay, then it matters to combination because the order doesn't matter. But whereas AB and BA does matter the order, so it comes under permutation. So AC and CA. Okay, A and C is the combination, B and C is the combination. But whereas this 6 AB, BA, AC, CA, okay, this comes under order does matter. All these 3 will be in combination. Okay, this you can find out very easily with a formula like N P R, where N is the total number of choices that is there in the set. Okay, and R is the number of choice we are going to pick from the set. Okay, that's our option is R. The total is the choices is the number n. Okay, so n factorial by n minus r factorial will give you the answer for how many permutations or how many combinations are occurred with order as a matter. Okay, so here n factorial, in this case the total number of choices is this 3, right? So 3 factorial by 3 minus r is 2. Okay. Is it, so it is 3 factorial, that is 3 into 2 into 1. 3 minus 2 is 1 factorial, that is 1. So it is going to be 6. So when we find the picture with the combinations written as such, we found it is 6 with the formula also. We found the same answer. So for finding combination, it is n c r, which is equal to p permutation by r factorial. Okay, p by r factorial. What is mean by that is the number of repetitions that have occurred AB and BA. That is the repetition of 1, right? For AC, there is a repetition of one more thing, C. BC, there is a repetition of CB. So the repetitions have to be eliminated by dividing them from the permutation answer. So for the previous sum, the permutation is, so the permutation value is 6. Or factorial is nothing but 2 factorial, right? We are picking out 2. So 2 factorial, so which is equal to 6 by 2 into 1, which is 3, the same answer, right? So either by combination using the formula, or by writing the combinations, we can find the number of combination or permutation, that is. So now we are going to check with this with some problems. In how many ways can a coach choose 3 swimmers from among 5 swimmers? Okay, the coach is going to select 3 swimmers out of 5 swimmers, right? So what we have to use? We have to use a combination formula or permutation formula. This is the doubt, right? So 3 swimmers are going to get selected. So they are going to be all swimmers. There is no different levels in that swimmers. Okay, they didn't say that they are going to win some prizes, this first swimmer or second, third place winners, nothing like that. They're just going to select 3 people from the 5 swimmers. So it is a order doesn't matter, so it is a combination problem. Okay, so 5 factorial by 5 minus 3 factorial into r factorial is 3 factorial, which is going to be 5 times 4 times 3 times 2 times 1 by 5 minus 3 is 2 factorial, so 2 into 1, and 3 factorial is 3 into 2 into 1. Okay, so 5 4s are 20 by 2, which is equal to 10. So there is 10 combinations by which the coach can select 3 swimmers out of the total 5 swimmers. Okay, next question. A maths debating team consists of 4 speakers. How many ways can the captain and vice captain be chosen? So there are 4 speakers, then they have to choose 1 person for captain and 1 person for vice captain. So they are going to choose 2 people out of 4, and here they are clearly given the 2 positions, captain and vice captain, right? So order does matter. So it is a permutation problem. So 4p2, it is n factorial is 4 factorial by n minus r, that is 4 minus 2 factorial, which is equal to 4 into 3 into 2 into 1 by 2 into 1, which is equal to 2. So there are 12 possibilities of selecting 2 speakers, one as a captain and one as a vice captain from the total 5 speakers. This can be, we can usually do in another format also. We are going to select 2 people, right? So we just put 2 dashes indicating that this is a captain and this is a vice captain. So out of the 4 speakers, one of the person has to be get selected as a, so there is 4 choices. When we are picking a captain, there are 4 choices, out of which we are going to select 1. And so already 1 person has got selected as a captain, so there are the remaining 3 speakers, out of which we are going to select the vice captain. So this gives the total number. Okay, this way also we can find the combinations. Okay, we'll see next 2 more problems. In a lottery, each ticket has 5 one-digit numbers 0 to 9 on it. So the total number of digits, that is n, is equal to 10. Okay, and they are going to pick 5. Okay, first condition is if you win, if your ticket has the digits in any order. What are your chances of winning, right? So any order, so the order doesn't matter. So we are going to do a combination problem. So n factorial is 10 factorial by 10 minus 5 factorial into 5 factorial is going to give a combination of odd 30,000 and something. Okay, 30,000 and odd. Okay, I don't know the exact answer. Okay, now we'll move on to the next sum. You would win only if your ticket has digits in the required order. Sorry, I just find this out and tell you. Okay, for this you would win only if their ticket has the digits in the required order. So in the required order, so there is a order is a matter, so we are going to do this as a permutation. Okay, so 10 factorial by 10 minus 5 factorial. Okay, okay, you have one more problem with your for your doing. You have to find out whether it is a combination or permutation, and update me. This value is 30,000 to 40, and here it is 252. Okay, 6 friends wants to play enough games of chess to be sure everyone plays everyone else. How many games will they have to play? In this we have to find, it is 6 friends, n is equal to 6. Okay, and they play, each one has to play with everyone else, and we know in chess there will be 2 players per game, right? So r is equal to 2. Okay, and so we have to find out whether it's going to be a combination or permutation and find the answer, and update me in the comment section.